Alright, so next we look at improper fractions. So we've mentioned and given a hint of these before, and we've talked about how we change them into mixed fractions, but then we're going to look at them in more detail now. So far we have only dealt with proper fractions, as I've been showing you, for which the numerator is of lower degree than the denominator. But now we can look at how to deal with improper fractions where the degree of the numerator is equal to or greater than the degree of the denominator. For example, x over x plus 1, as you can see, that's already an improper fraction. X squared plus 1 over x. Then we have x power 4 plus x plus 1 over x into x minus 1, x plus 2, x plus 3. So that's another example of an improper fraction. So those are the kinds that we're going to deal with. Alright, so let's look at an example. So we're being told to express 4x cubed plus 10x plus 4 over x into 2x plus 1 as a partial fraction. So let's look at this fraction critically. So this is what we have right there. As you can see, if you look at the denominator, of course we have two linear fractions. As you can see, we have the x, we have two linear equations. We have the x and then we have the 2x plus 1. This can be considered as two linear fractions. But then let's look at this to show that the powers at the denominator are really lower than those at the numerator. So you can see that at the denominator we have the highest power, or the highest degree, which is 2. Then at the numerator the highest degree is 3. So this is actually an improper fraction. So you can say the degree of the numerator 3 is greater than the degree of the denominator 2. So this is an improper fraction. So when it comes to improper fraction, we're going to employ long division, and then we're going to actually convert that into a mixed fraction. So by long division, we're going to divide. So now we're going to place in brackets. So this is the value of the numerator value. But as you can see, in the numerator value, we had 4x cubed plus 10x plus 4. So we didn't have the region for 0x squared. We didn't have, but we're going to assume that the coefficient there is 0. Then we have this dividing the 2x squared plus x, which is the value that we have at the denominator. So when you divide this, 4x cubed divided by 2x squared is going to be equal to 2x. So 2x times 2x squared is going to be equal to 4x cubed plus 2x squared. So when you subtract that, 0x squared minus 2x squared is going to be negative 2x squared, as you can see right there. So we're going to have a negative 2x squared plus 10x plus 4. And then negative 2x squared divided by 2x squared is going to be equal to negative 1. Now the reason we keep on dividing is because we can actually see that now after we've divided the first time, we actually now compare, is this power here now less than this power here? As you can see, they're still equal. So that means we actually need to divide again. So now we have, so since we're going to divide again, we have negative 2x squared divided by 2x squared, which is going to be equal to negative 1. Negative 1 times this is going to be equal to negative 2x squared minus x. So when we subtract that again, we're going to have 11x plus 4. Now this and this cancel, and we'll have 10 plus x, which is 11x, then 4. So that's what we have there. So now writing this as a mixed fraction, we'll have 4x cubed plus this. We're going to have our fraction being equal to 2x minus 1 plus 11x plus 4 over x into 2x plus 1. So now this is what we have. So now this is our mixed fraction form. So now after we've converted it into a mixed fraction, now we can deal with this part right here and convert this into partial fractions. As you can see, now we are going to be dealing with linear partial fractions. So now let's deal with that. So we're going to let that 11x plus 4 over x into 2x plus 1 be equal to that. Since we're dealing with linear partial fractions, we're going to have an a over x and a b over 2x plus 1. So when you find the LCM there, this is going to be our LCM x into 2x plus 1, and these shall be our values at the numerator. So now we can say the denominator values cancel, and then we actually now can find the value of a. We can find the value of a by letting b be equal to 0. but instead of doing that, we can actually just solve directly. This will actually save us time. So let's open brackets. We have 2ax plus a plus bx. So now let's combine the values that actually have the power of x, x power 1, just like we have there. So let's group them that way. Then we're going to compare the coefficients on both sides. So you can see that a, actually when you look at this, a shall be equal to 4. So we now know the value of a. And then 2a plus b is 11, but we know what a is. A is 4, so we have 2 times 4, which is 8. So 8 plus b is equal to 11, and b shall be equal to 3. So therefore, our equation shall be equal to, now this is the mixed part, but now where we had the other side, we're going to replace that with the partial fractions. So we're going to have 2x minus 1 plus 4 over x plus 3 over 2x plus 1, and that is what they wanted. Let's look at another question. So this is another question. We have 2x cubed minus x minus 1 as a partial fraction over x minus 3 to x squared plus 1. Alright, now let's look at this critically again. So as you can see, when you open these brackets, you can actually see that the highest power at the numerator is actually the same as the highest power at the denominator. So this is an improper fraction. So you shall need to employ long division. So degree of numerator and denominator are equal. So this is an improper fraction. So by long division, we're going to divide that numerator value. So this divide by that. So as you can already see, we've added this just as an extension, because we know that the coefficient at the x squared for this is actually 0. So that's what we've actually pasted there. So 2x cubed divided by x cubed is actually equal to 2. So 2 times this, we have 2x cubed minus 6x squared plus 2x minus 6. So when you subtract that, we have 6x squared minus 3x plus 5. So now we compare the power here with this power here. As you can see, it's already less than this power here. So actually we can stop there with the long division. So therefore our mixed fraction shall be 2 plus 6x squared minus 3x plus 5 over x minus 3 into x squared plus 1. So now next we can actually now deal with this part right here. So let's deal with this fraction right here. As you can see, in this fraction we have a linear factor, but we also have an irreducible quadratic factor. So that's why we have a over x minus 3, and then for this we have bx plus c over x squared plus 1. So that's why we have it that way. So next, when you find the LCM is x minus 1 into x squared plus 1. Get this, divide by x minus 3, and you have x squared plus 1. Multiply that there. This divide by x squared plus 1, and you have x minus 3. Multiplying there, and that's what we have. So the denominators cancel, and this is what we remain with. So now the next step is going to be, we're going to need to solve for a, and then we can use that to find the rest. So as you can see from here, we can actually find the value of a by letting x be equal to 3, because it will make this 0 and this will cancel, then you can find a. So if we let x be equal to 3, this is what we have. We shall have 50 being equal to 10a, and a shall be equal to 5. So now that we know what a is, we can actually now just use this expansion, this equation, just expand it, and wherever there was an a, we're going to place that a 5. So this is what we shall now have. So when you open these brackets, we can actually see that this, we shall have 5x squared plus 5. Then right here, this bracket times this bracket is going to be bx squared minus 3bx plus cx minus 3c. So when you collect terms that actually have the same powers of x, so these are the terms that have x squared, the terms that have x, and then those that don't. So when you group them together, that's actually what we have. So now we can compare the corresponding coefficients, and we can see that we'll have 5 plus b being equal to 6. Then from there we can see that b is equal to 1. And then you can also see that 5 minus 3 is equal to 5. So 3c is equal to 5 minus 5, of which c shall be equal to 0. So therefore, this is what we have. We have 2 plus 5 over x minus 3 plus, b is 1, so that means 1 times x, and then plus 0. So we'll be left with 2 plus 5 over x minus 3 plus x over x squared plus 1, and that is the answer they wanted. Alright, let's move on to question number 3. So we're being told to express x power 4 plus 3x minus 1 over x plus 2 into x minus 1 squared as a partial fraction. So as you can see, when we open the brackets at the denominator, this is what it actually looks like. So therefore, we can see that the degree of the numerator is greater than that of the denominator. So that means that this is an improper fraction. So now we're going to solve that by long division. So we have this value right here. As you can see, where we have x squared, x cubed plus x squared, we're going to assume that the coefficients of those parts were actually 0. Then we're going to place that in there. Then right here, we're going to have this, it dividing by that. So now when we have x power 4 divided by x cubed, the answer is x times this, we have x power 4 minus 3x squared plus 2x. So when we subtract that, we can actually see that now we have 0x squared minus negative that, so it's going to be 0x squared plus that. So we have 3x squared, positive 3x squared, then 3x minus 2x is x, and then negative 1. So that's why we have it like that. So therefore, this is how it looked at as a mixed fraction. Now the reason we stop is because this power here is already less than this power there, so we no longer need to continue with the long division. So this is our mixed fraction. So now solving for this, we're going to solve for that now. So let's solve for that. So we're going to let this value be equal to that. As you can already see, we already have a repeated factor right here. We have x minus 1 squared. So we're going to deal with it, they will deal with the repeated factors. But this one is a linear factor, so it's going to be x over x plus 2. But since this is a repeated factor, we'll have a b over this to the power 1 and a c over this to the power 2. Alright, so the LCM shall be x plus 2 into times x minus 1 squared. So when we get this, divide by x plus 2, we'll be left with x minus 1 squared. So we multiply that to the a. So when we get this, divide by x minus 1, we are left with x plus 2 into x minus 1 to the power 1. When we multiply those two, the b. So now when we get this, divide by x minus 1 squared, we're left with x plus 2, multiply x plus 2 to the c, and that's what we have. So now the denominator values cancel, and this is what we are left with. Now as you can see, we're going to apply some knowledge to actually first find. We're going to need to at least find one of the values. And as you can see, this will actually easily work out. There are different values you can actually easily let. We can actually see that it's possible if we want to find the value of a, we just need to let x be equal to negative 2. If we want to find the value of c, we'll just have to let x be equal to positive 1. So either of those will actually help us. So if we let x be equal to negative 2, we have this. So we shall have 9a being equal to 9, of which a shall be equal to positive 1. Now we may not need to solve it the other way. We can just since we at least know one of the values, it's going to be easy to find the remaining two. So we're going to just get back to the equation, and we're going to substitute in the value of a as 1, and then we're going to just open brackets and solve. As you can already see, when I open these brackets, x plus 2 into that, this is what I get as an expansion. Then x minus 1 squared shall be equal to x squared minus 2x plus 1, and that's what I have. So multiply this b inside, and this is what you end up with. So now I'm going to group terms that actually have the same power for the value of x, and this is how they looked when they're grouped. So now that they are grouped, I can now compare the corresponding coefficients on both sides. So it shall be c at 1 plus b is equal to 3, and b shall be equal to 2. Then we have b plus c minus 2b being equal to 1, which you know that b is equal to 2, so c shall be equal to 1, as you can already see. So therefore we'll have our fraction being equal to x plus 1 over x plus 2 plus 1 plus 2 over x minus 1 plus 1 over x minus 1 bracket squared, and that's going to be our answer. Alright, in question number 4, we're being told to express x cubed minus 3 over x minus 2 into bracket x squared plus 1 into partial fractions, and hence evaluate this integral. So we're going to have to integrate it after. So before we integrate, definitely we need to first simplify that and convert into partial fractions. So as you can see, this can be expressed that way when you open the brackets at the denominator, and you can already see that the degree of the numerator and the denominator are equal. So this is an improper fraction, so we're going to have to use long division. So by long division, we're going to have this, but now we're going to add the missing coefficients. So we have 0x squared plus 0x, so that's just to make it look neat, minus 3, dividing that. So we're going to have it dividing that value. So x cubed divided by x cubed, so this divided by this is going to be equal to 1. Then when we multiply 1 to this, we'll have that. We'll have x cubed minus 2x squared plus x minus 2. So let's subtract those, and we'll have, as you can see, 0x squared minus negative this, so it's going to be 0x squared plus 2x is going to be 2x squared. Then we have 0x minus x is going to be negative x. Then negative 3 minus negative 2, which is like negative 3 plus 2, is going to be equal to negative 1. So we have negative 1 there. So therefore our mixed fraction shall be 1 plus 2x squared minus x minus 1 over x minus 2 into x squared plus 1. So now we're going to solve for this part right here. So we're going to let that part be equal to that. As you can already see, we actually have an irreducible quadratic factor right here, and we have a linear factor right here. So for the linear factor, we just have an a over x minus 2, but this quadratic factor, we're going to have it as bx plus c over that value right there. So next we're going to find the LCM, and the LCM shall be x minus 2 into x squared plus 1. So when you get this LCM divided by x minus 2, we're left with x squared plus 1. We multiply it to the a. This LCM divided by x squared plus 1, we're left with x minus 2. Multiply that to bx plus c, and that's what we have. So now we can see that these denominator values cancel, and this is what we're left with. So now we need a way of finding at least one of the unknowns. As you can see, I can easily find a by letting x to be equal to positive 2, and this will become a 0, so this will cancel and I can find a. So if I make x be equal to 2, I can actually see that we'll have 5 being equal to 5a, and a shall be equal to 1. So now I can just solve for the equation, and then I'm just going to replace wherever there is an a, I'll just put a 1, and then I can just simplify. So when I open these brackets right here, I'll have bx squared minus 2bx plus cx minus 2c. And then I'm going to combine all those that actually have the same power. So those that have x squared are going to combine together, those that have x are combined together, and those that don't also combine together. So now this is how they look when they are grouped together. So now I can actually equate corresponding coefficients on both sides. So I'll see that 1 plus b shall be equal to 2, and b shall be equal to 1. And then c minus 2b is equal to negative 1, but b, remember, is 1. So I'll have c being equal to 1. So therefore, our equation shall be equal to 1 plus 1. So the partial fractions are 1 plus 1 over x minus 2 plus x plus 1 over x squared plus 1. And that is what they wanted. And now we're going to integrate these partial fractions. So how does this work? Let's integrate them. So now, as you can see, this can actually be broken up and split into two other different fractions. So this is the same as x over x squared plus 1 plus 1 over x squared plus 1. So that will make it easier to solve. And as you can already see, that when you integrate 1, it's actually going to just be equal to x. When I integrate this, it's going to have a ln, so this is going to be ln x minus 2. Then as you can see here, I can actually just use u substitution right here. Then when I use u substitution, it will actually give me the answer. Then right here, we're actually going to have to employ trigonometric substitution using tan. So when you do that, we'll end up having x. Here we'll have ln x minus 2. Here we'll have a half ln x squared plus 1. Then for this, after applying trigonometric substitution with tan, we'll have tan inverse of x plus c. Now I can simplify this further. I can actually see that this half can be made a power of this bracket, so it will be equal to x squared plus 1 to the power half, which is the same as root of x squared plus 1. And as you can see, a lean plus a lean is the same as their product. So it's the same as lean x minus 2 times x squared plus 1. And that is how it will look. So therefore, the integral of this shall be equal to x plus lean x minus 2 times x squared plus 1 plus tan inverse of x plus c. And that is the answer they wanted. So this is a question from UNEB 1993, and we're being told to try it out. So we're being told to integrate lean bracket x squared minus 4 dx. Now this one is an example where this property of improper fractions is actually just a step. So this number is actually a long one. It looks simple, but it's actually a very long one. But what we're going to do is we're going to solve it step by step until we understand it properly. So as you can see, this number here requires us to first use integration by parts. So in integration by parts, we're going to assume that there is a 1 multiplying the lean x squared minus 4. So we're going to let u be equal to lean x squared minus 4. Then we're going to let dv dx be equal to 1. As you can see, the best way of solving this is by adding an e to both sides, and we'll have e lean that. And then I'll have eu being equal to x squared minus 4. Then du dx shall be equal to du dx eu shall be equal to 2x, and therefore we can see that du dx shall be equal to 2x over eu. But eu is x squared minus 4, so that means du dx is equal to 2x over x squared minus 4. Now right here, to find the v value, we can see that we just have to integrate the 1, and v shall be equal to x. So now from the formula of integration by parts, this is what we have. So we're going to substitute in the values. So where there is a u, we're going to substitute in our u value, we're going to substitute in our v value, minus integral of, so we're going to substitute in the v value, the du dx value dx, and that's what we have. So now this is what we end up having, but we can actually see that this part here still needs to be integrated even further. So let's look at this integral now here critically. Alright, so let's look at this integral here. So as you can see, the denominator is actually a difference of 2 squares, but before we even do that, we can already see that the power of the numerator and the power of the denominator are already equal. So this is actually an improper fraction that we're dealing with. So as you can see, the degree of the numerator and denominator are equal, so this is an improper fraction. So by long division, we're going to have to simplify that. So we have 2x squared plus 0x plus 0. So let's just solve for that into x squared minus 4. So we're going to divide it by x squared minus 4. As you can see, 2x squared divided by x squared is 2. So 2 times x squared minus 4 is 2x squared minus 8. So subtract that, and as you can see, we'll have a remainder of positive 8. And why is that? It's because 0 minus negative 8 is like 0 plus 8, which is 8. Then the rest just cancel. So therefore, our mixed fraction shall be equal to 2 plus 8 over x minus 2, x plus 2. Remember that this x squared minus 4 is the difference of 2 squares, so it can be expressed this way. So we're going to let 8 over x minus 2 over x plus 2 be equal to a over x minus 2 plus b over x plus 2, because now these are actually linear factors. So when you find the LCM shall be x minus 2 into x plus 2. So when you divide this by x minus 2, we have x plus 2 times a. Divide this by x plus 2, we have x minus 2 times b. And then you can say the denominator values cancel, and we're left with 8 being equal to that. So as you can see, the easiest way of solving is now for us to find the value of a, we're going to first let the x be equal to 2. So if x is equal to 2, we can actually see that this is what we end up having. So this actually becomes 0, and then we're left with a, 4a being equal to 8, which a shall be equal to 2. Alright, so next we're going to make use of this equation right here again, but now the difference is wherever there was an a, we're going to substitute in a 2. And this is what we end up having. So you can open these brackets, and we'll have 2x plus 4 plus, open these brackets, bx minus 2b. And then we're going to group the terms that actually have an x and the terms that actually don't have an x. So we have 2 plus bx plus 4 minus 2b. And then now we can equate corresponding coefficients on both sides. So we shall actually see that 4 minus 2b shall be equal to 8, of which 2b is equal to negative 4, as you can see, because 4 minus 8 is negative 4, and then b shall be equal to negative 2. So therefore, we have 2 over x minus 2 minus 2 over x plus 2 as that part for the partial fractions. So therefore, our general fraction shall be equal to 2 plus 2 over x minus 2 minus 2 over x plus 2. So now, we remember that we're integrating it, so we're going to integrate those partial fractions, because now we need that answer for the integral of 2x squared over x squared minus 4. So when you integrate this, we can actually say, I can actually pull out a 2. A 2 can be factorized out of all, and then I can actually see that here, definitely the integral of 1 is x. The integral of this, using u substitution, you'll see that it will have ln x minus 2. And then right here, the integral of this shall be equal to ln x plus 2, also using u substitution. So multiply these 2 inside the brackets, and we'll have 2x plus 2 ln x minus 2 minus 2 ln x plus 2 plus c. So this can also be arranged this way, because a ln minus a ln is like division. So I have this divided by that with a 2 outside, because there is a 2 in common on both of them. Then we can take back to the original integral, because remember that we're dealing with integration by parts at the very beginning. So how will this look? So this is what we'll have. So now we have ln x squared minus 4 being equal to x ln x squared minus 4 minus this. But now remember, we found the value for that. So now we have this minus that. So when you open these brackets, we can actually see that we have a minus 2x minus, so this becomes a negative minus 2 ln x minus 2 over ln x plus 2 plus c. So therefore, the integral of x squared ln x squared minus 4 dx shall be equal to x ln x squared minus 4 minus 2x minus 2 bracket ln x minus 2 over ln x plus 2 plus c. And that is what they wanted. Now I have an exercise for you. So in this exercise, you're being asked to express as partial fractions. So I encourage you to try out the following and get better. So you're going to express part 1 to part 5 as partial fractions, and then the answers are right here for you to compare with what you get. So these are the first 5 questions for you to try out, so you can try these out. So now the next questions are going to be expressed as partial fractions and hence evaluate the following. So these ones you actually just have to get the integrals also. So express as partial fractions and also integrate, and then compare your answers to what we actually have right here. So this is part 1 to part 5, and then I also have part 6 of it as the continuation of that. Otherwise, thank you so much for watching. So these are the answers. Otherwise, thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.